In this topic, we are going to learn about independent events. Two events are independent if the occurrence or non-occurrence of one event does not affect the occurrence of the other event. For instance, here we have two coins. Let event 1 be the probability of getting a head by tossing the coin, and event 2 is the probability of getting a head by tossing the other coin. The probability of getting a head here for the first coin will not affect the probability of getting a head for the other coin. The probability of getting a head for the other coin will always be 1 over 2 regardless of the result for the tossing of the first coin. Here we have a coin and a die. Let event 1 be the probability of getting a head and event 2 be the probability of getting a 1. Similarly, probability of getting a head here for tossing a coin will not affect the probability of getting a 1 for tossing the die. The probability of getting a 1 here for the die will still be 1 over 6. In this next example here, we have a deck of cards. Let event 1 be the probability of getting an ace from this deck of cards, and event 2 be probability of getting a heart. Now, if I draw an ace, there's a chance that I may draw an ace of hearts, and hence it will affect the probability of getting a heart later, as I may have one ace less. Therefore, these two events are not independent, as drawing an ace may affect the probability of getting a heart later on. Now, what happens if event 1 is the probability of getting an ace? However, we replace the card this time round, and event 2 is the probability of getting a heart. Then, these two events are independent, because in the events that we get an ace of hearts, the ace of hearts will be replaced, and it will not affect the probability of getting a heart for the next event. In this example, two unbiased coins are tossed. Tossing two unbiased coins is the same as tossing an unbiased coin twice. The probability for these two will be the same. We are asked to find the probability of getting two heads. Now let us use a possibility diagram to help us to answer this question. For coin 1, the possible outcomes are either a head or tail, and similarly for coin 2. And the possible final outcomes are head-head, head-tail, tail-head, or tail-tail. The probability of getting two heads, there's only one outcome favorable to getting two heads, and there are 4 possible final outcomes. And therefore, the probability of getting two heads is equal to 1 over 4. Now, the probability of getting a head for the first coin is 1 over 2, and the probability of getting the head for the second coin is also 1 over 2. If we multiply these two numbers, we will also get 1 over 4. In this next example, a spinner is spun and a die is tossed. We are asked to find the probability of getting two 5s. Again, we will use a possibility diagram to help us to answer this question. And let us fill up the sample space. And we notice that there is only one outcome that is favorable to getting two 5s. And hence the probability of getting two 5s will be equal to the total possible outcome here is 30. And the number of outcomes favorable to getting two 5s is only 1. Now, if we use the probability of getting a 5 for the die to be 1 over 6, and the probability of getting a 5 for the spinner is 1 over 5, if we multiply these two probabilities here, we will also get 1 over 30. Hence, if two events A and B are independent, then the probability of getting A and B will be equal to the probability of A times the probability of B. Here we have a bag containing a green, red, and orange ball. A ball is taken from the bag at random and replaced before taking out another ball. Find the probability of getting two green balls. The probability of getting two greens is the probability of getting a green and another green. In this case, the first ball is replaced before getting another ball. And we have learned earlier that this is equal to probability of getting a green times the probability of getting a green. The probability of getting the first green is 1 over 3. Since the ball is being replaced, the probability of getting the other ball is still 1 over 3. And we multiply these two numbers together to give us 1 over 9. In summary, if events A and events B are both independent events, then the probability of getting A and B will be equals to the probability of A times the probability of B. And that's all for this topic.